And now I am delighted that we're joined by Sydney and Amy from House Motion. Um, and they are going to be talking today about turning large scale biomechanics into real world impact. So thank you so much. I will hand over to both of you.
Perfect. Thank you. I'll just share the screen now. Hopefully that looks okay. Okay, let us know if you can't see anything.
It looks great.
But perfect. Thank you so much for having us. It's been great for us to be able to work with IWB, but also for Has Motion to be able to sponsor some events. So thank you for giving us a chance to kind of talk a bit about what we do and also what we kind of see the community doing as well. So we're going to be focusing a bit on the idea of what we're kind of targeting right now at Has Motion is this idea of turning large scale biomechanics into a real world impact. So I think this idea of big data, large scale data sets have been a topic for a while. They're definitely happening right now. We see everyone in the community kind of talking about it, working towards it. So we just kind of wanted to go through how we are approaching this topic, and then also more specifically how we have some users who are working towards it, and just to kind of give a chance to highlight some really cool things that are happening. So a bit of overview of what we're going to go through. We'll start obviously with just a bit of who are we in case you don't know. We'll then go into the idea of what is big data and what does big data mean for biomechanics. And then finally, we'll start to highlight some users of ours, but also just people in the community who are tackling this idea of big data and how they're going about that to get some really cool results. So to begin, Has Motion. If you're not aware of us, you might be aware of Visual 3D, which is one of the softwares that we develop. It's kind of our big name and big product that is the most recognizable. What we do is we develop software for biomechanical analysis, Visual 3D, as I mentioned, the most common here. It's research software that can be used for complex biomechanical modeling and data synthesis. Very, very much focused on motion capture. That's kind of what Has Motion specializes in, but not just motion capture. We have EMGs, IMUs, force platforms, etc. But 3D motion capture is really where we can go complex with our research. A little more new is our another product, Sift. And this is a kind of an add-on software application that we have been working towards and we have been working on to kind of going hand in hand with this idea of big data. So it's another tool that is allowing people to kind of generate all of their data into one place, being able to visualize, analyze, clean, etc. your data, to be able to kind of have this idea that in the past, biomechanics have really been not that many participants, but right now we can have a lot more participants. We can gather them all in one area and we can start to look at them to be able to do some follow-on analysis. And this is just kind of the overarching goal is at the end of the day, we're building these software to be able to analyze human movement, but really just be able to use this movement as a biomarker and kind of helping us with understanding this language of movement and how can we actually get meaningful results with it. So a bit more, less on the technical side, who is Has Motion and where are we? We're in a smaller city, Kingston, Ontario. If you're not too familiar with it, it is kind of halfway between Montreal and Toronto. And as you can kind of see, we have, like any good Canadian city, all 4 seasons. We're right on the lake, so we have a beautiful summer. In that photo, it's the yacht club, and we're just about 10-minute walk from there. So it's quite nice. A little more, unfortunately, though. It's looking a bit, it's getting a little nicer, but maybe a few days ago it was really looking like that middle photo there. The groundhog, I think, lied to us that we're having a long winter. But yeah, no, it's a nice city. Hasmotion is Visual 3D has been around for a while, but Hasmotion is really starting to get established in the last few years. So it's nice to be in kind of a smaller city and get to work and see work that's going around the world. So a little bit about us. I'll do my first introduction, then I'll pass it on to Sydney. But I'm a biomechanical engineer at Hasmotion, been here for the past couple of years. I also do a lot of the research, internal research here at Hasmotion. So my work has been trying to adopt machine learning techniques found in other fields, apply them to biomechanics to kind of look at this idea of big data and how can we start to extract patterns, anomalies, etc. So that's just a little bit of the work that I do. And then Sydney.
Yeah, hi everyone. So my name is Sydney. I'm also a biomechanical engineer here at Hasmotion. My background is very similar to Amy's. We both started at the same time as summer interns at this company, and then both were hired after that for full-time positions about 3 years ago now. So yeah, we've really gotten to see kind of how Hasmotion has grown. I think we were employees like 3 and 4 technically when we were hired. So it's been really fun to feel kind of like a startup, but we have this long-standing kind of reputation in the field, I guess, with Visual 3D and Scott Selby, our CEO, and his kind of position here in the biomechanics and specifically kind of motion capture field as well. So yeah, just want to say we're super excited about being here and talking to you guys, sharing what we do. And hopefully this can be interesting for those who also maybe aren't necessarily in like the motion capture space as well. But yeah, so my specific role, I kind of focus more on integrating kind of our ideas that we might have from some of the internal research we do or from what users in the field are doing and translating those into our software applications. So trying to work closely with our software developers or do the development myself and try to kind of bridge that gap of what are the users looking for and how will this actually be applicable in the biomechanics field and how we do research and how should this be integrated in the software as well. So that is a little bit about my role. Yeah, so
just to add on there, we forgot to mention that we are also both quite involved with the IWB. So I just wanted to shout out again what you mentioned at the beginning. We are part of Sydney's the conference head, team lead on the social events. So I just wanted to plug that World Congress social event as well. Hope if any of you guys are going to the conference that you guys come to the social event too.
Yes, I think it's going to be great. And yeah, we're hoping to have like record-setting numbers. So everyone yes, we have been involved with at IWB for, I guess, over a year. Started as volunteers on the conference team under Cheryl, and now I'm kind of leading the team. So it's been it's really great as well to be involved with IWB. So thank you guys. Yeah, so into this idea of large data, really our kind of motivation and direction at Hasmotion kind of shifted when we saw this kind of shift in the field of motion capture towards big data, really with kind of the adoption and an acceleration of the production of markerless motion capture. We've found that multi-centered studies are increasing and kind of the need to share and pool data is becoming more prevalent. And this idea that if we're going to kind of tackle and try to represent a subset of the population to be able to collect enough data. At some point, we're going to have to pool and share this data, or so some think. So as developers of analysis tools, we kind of feel this sense of responsibility to make sure that you guys can do this correctly as users, and then make this kind of possible for you to do. So we want to kind of ensure that the necessary rigor is kind of present to ensure you can like effectively manage the data, process and analyze big data, and then have the infrastructure in place to achieve this on like a multi-centered scale as well. And then also be able to have tools that allow for a common language across your projects, across the whole lab, across collaborators, and have kind of these tools in place that scale to whatever project or size of ecosystem that you are working in this environment. So yeah, that's what we've gathered from the customers and users that we've interacted with, and what people are really needing from us right now. So this has been an interesting kind of topic for us to look at. And so this is kind of the call to action for the biomechanics field that we've kind of seen. So yeah, we're going to continue to talk about kind of how this big data has kind of progressed and what that means. So traditional biomechanics, as we all know it, limited to in-lab, a very controlled environment, sometimes requires very narrow questions. So there is some limitations to based motion capture and what we are able to do kind of in this traditional lab setting. Although obviously we've been able to do great things, and it's opened a lot of doors for biomechanics. But of course, we didn't know what we didn't have until markerless motion capture came out. And so having this ability to collect big data, go out in the world, collect in real world situations, which will kind of show examples of like, we can collect at like live events and just situations that would never have been possible with something in like a traditional sense. And then just the ability to collect like so much more data when we're able to just like collect lots of people all the time. We also just have so much more data that we don't know what to do with, basically. So we like to show this video. Let's pause it so before I actually play it. We kind of like to show this video. It's like just a nice touch on kind of showing the impact of markerless motion capture, and not to like hate on marker base, but like more just showing like the actual the challenges or some of the limitations that marker base potentially has, and how like dramatic it really is that we can just collect so much quicker. So this video is from Jeremy Outerlay's, but I believe it was through Thea Markerless, which is a markerless motion capture company, also based out of Kingston, Ontario, but essentially showing the standard like protocol setup, calibration for a single collection in this lab. And this lab is based out of Hotel Dieu in Kingston, Ontario, from Queen's University, the Human Mobility Research Lab under Dr. Kevin DeLuzio, if you're familiar. And this is a lab based in a hospital, and so they're kind of working on collecting patients with primarily osteoarthritis patients pre-post operation, and with the addition of they've collected a lot of people with marker base, but with the addition of markerless, like hundreds and hundreds of people, and they just it's kind of standard protocol that they go to their operation or see their doctor, and then they're like, okay, go downstairs and walk through this motion capture lab in 5 minutes, and you'll be able to they'll be able to collect your data. So yeah, I like this video just to kind of show basically a timestamp side by side of from start to end of marker based on the left and then markerless on the right, and at the end they'll finish at the same time. And it's just kind of a nice, really puts it in perspective, say. So like the standard marker set, and really the bulk of the time, which we all understand. Calibration. All right, so now actually doing the trial, taking off the markers, and then calibrating and taking the trials. So we're able to kind of achieve effectively the same collection in 2.5 minutes versus 45 minutes. So just a nice little video for that break. Anyways, so when it comes to processing big data, after we've collected large groups and we're able to collect lots of different people in lots of different places, and even just with standard motion capture labs as well, just what do we do with this big data? Well, sometimes and most of the time we're looking for detecting some sort of outlier characteristic or anomaly from this data set. So can we actually figure out something, some individuals who have something special? And it's often thought that like we could just take this large data set, throw it into a machine learning algorithm, and then it'll spit out these individuals. But it is actually a lot more complicated than that. These large data sets require a lot of preparation, shaping, cleaning, grouping, figuring out what we want to include and remove before we can actually move them into machine learning. And so that's kind of where we fit in with Visual 3D and SIFT, and why these software applications have been developed to kind of help you achieve this, we call the knowledge discovery process of gathering, cleaning, shaping, analyzing, reporting data before we can kind of put it into that machine learning part of this kind of process. So that was a little bit on what we think is happening with big data right now. This kind of the doors that are opening with markerless motion capture, and where we think our software applications fit in, or why we care about this. But we don't want to just keep talking about ourselves, because we think there's some cool people in the world doing really cool things. And we wanted to share like how they've been able to achieve some of the topics we've already discussed, and how essentially how we've seen them do that, and how they've been able to use our applications to help them with that.
Yeah, so I'll take over for a bit now, go over the first of 3 user stories. And we kind of wanted to highlight what someone was working on, but then just kind of going back to the idea of big data and focusing on one of the things that that study really focused on, and kind of showed that shows that big data might need a bit more consideration or thought process, or maybe changing the way we do things, just to be able to keep up with the study and the data that's getting collected. So the first one we're going to talk about is multi-centered studies. So I think I've been seeing this a lot more in journal articles, and just talking with people, is this idea that pooling data has become a big topic about, if everyone is collecting data, is there any way that we can start to share this data? Obviously, there's a lot of complications there with the idea of standardization of data, getting into ethics and requirements and all those questions, big questions that are not easy topics, but I think something that is kind of at the forefront of people's minds right now. I think it was an ISB, and there was a talk there about, is if we start to think about sharing data, what's that going to look like? But we wanted to highlight this one multi-centered study that was a group of people who have started to think about it and have actually done it. So one of the things that they really touch about on this article, which I'll share with you in the next slide, is the idea that if we want this idea of big data to become accessible for everyone, we're going to need to start building some large longitudinal studies that really require this idea of multi-center studies. To be able to do this, it's not going to be a small feat. We need a unified framework to standardize the data collection, anatomical modeling, biomechanical measures, etc. We need to make sure that communication with different groups is very clear and standardized. But at the same time, it is necessary to be able to aggregate these data sets so we can start to have a bit more robust modeling and generalizable clinical insights. Touching again on what HesMotion does, this idea that tools like Visual 3D can kind of help with this idea of standardization. It's a tool that allows, when you're doing your processing of your data, there's always going to be a signal processing history, which means that these definitions for some of your anatomical modeling, biomechanical measures will get saved, and you can start to communicate with different collaborators. But yes, specifically, we're talking about the journal article that was published a little bit ago. I want to say November of 2025. Again, it's works with the Human Mobility Research Lab that was actually shown in the last video. It's HMRL. It's at the Hotel Jarrett and Queen's University of Kingston, and they worked with two other sites. They were looking at Dalhousie University and the hospital associated there, and as well as McMaster University and their respected hospital. And what they were looking at is knee osteoarthritis. Can we be able to collect data in 3 different sites and be able to pool it and get insights? Or are the differences between these 3 centers too great to be able to actually start to compare the data? I think one of the really coolest things here was the clear visual that every study's lab space is a little different. They were all using biomarkerless, but even then, their setup is all different. So within these 3 sites, you can see 3 very different spaces. You have the first one, which is a very standard, very nice space. If you get to think about it, you get a good distance to be able to be flexible with your space to collect data. The third one's a little bit more restricted, but it's still definitely feasible. And then the middle one, I think, is a very interesting example of use what you have. I think it was a hallway in a hospital, really don't have a lot of space, but still being able to collect data in such that it can get shared and be used for multi-center. So I actually have a video here that this is this McMaster hallway that is a very small space, but they were able to make it work. You can see that it's like a curved hallway, a little limited, but still being able to collect data.
Yeah. And it's like super, I think it's like right outside the doctor's office. So it's like, as you walk to or from your appointment, they're like, oh, well, we'll just collect your data while we're at it. So if you're thinking of ideas, or if you have someone who tells you you can't have a motion capture space, think about the hallway outside the doctor's office.
But yeah, to go back to the journal article, some numbers here. They were able to look at 486 participants, 351 with knee osteoarthritis, and 135 asymptomatic participants. As I mentioned, they were able to use Visual 3D to kind of have a standardized processing pipeline to be applied to all C3D files that were coming as the output of VIA. And so with this standardized processing pipeline, all of the data could be analyzed in the same way, even if they were collected at different sites. You could then use SIP to be able to do some quality assurance. Again, just verifying you were happy with all of the biomechanical measures that were getting computed. So yeah, they looked at temporal distance metrics and joint angles, and they found that the kinematic differences between all of the participants and all the different sites were below reported estimates of measurement error due to intersite effects. So they were quite happy. It was the first multi-center study to show that markerless motion capture can reliably detect clinically meaningful gait deviations in individuals with knee OA across varied clinical environments. So that just the idea that the differences you're finding within the data are differences from the participants and not differences from the different sites. So just being able to look at that, and they were quite happy. So it's just to show that this is getting done and it is possible.
And correct me if I'm wrong, Amy, but I believe also, I don't remember if it was this study or another study, but the idea of like having kind of a standardized pipeline where we're able to process and create these process signals meant that they could share the process data and not the raw like patient information data.
Yes.
Yeah. So they could pool like, yeah, there's like that kind of separate step to kind of consider those limitations of working with patient information. Yeah, so to touch on kind of the next user story, one thing we have thought about and worked a lot with, particularly in collaboration with this particular project, is this idea that big data requires a streamlined output and a streamlined process from start to finish, especially if we're working on projects where we're continuously adding data or collating data. This is definitely necessary. So this next story is the Sanford STRIDE project, which maybe some of you are familiar with. But in kind of a recent sports science milestone, researcher out of Sanford Health, so the director of Sanford Health Center for Biomechanics and Movement Science, Colin Bond, had him and his team complete a motion capture feat recording hundreds of marathon runners. So they actually set up an outdoor markerless motion capture collection project at the Sioux Falls, I think, marathon, with 3D pose estimation for more than 350 marathoners. And so it was at kind of like a certain mile of the race at mile 20. So all runners that ran through got their biomechanics data captured. And if they opted in, they were their data was added to this open source data set, which I will touch on in a few minutes. But this was a kind of really unique example of like, hey, we can actually collect like a real life marathon event. And we don't have to like try to put markers on people, and then that's probably going to affect how they're running. And we can kind of nonchalantly like set up this markerless motion capture and just be able to collect like a real race, which is super cool. And to be able to collect 350 marathoners in a day is like, that's would have never been possible before. So we think this is a really cool example of some of the things that we're starting to see in the field. And so just to touch on, of course, we don't require any markers, and it also opens up, well, there we go. What I just said opens up new types of data collection and new questions, which kind of is the key there. It's like, not only can we collect lots of different things now, but we can also like ask questions related to that and kind of new research questions that we couldn't before. And so this is really not a typical amount of data to manage. Having 350 marathoners in one day or just trials in a day, we're not used to that. So they were able to use Hasmotion's applications, specifically setting up processing scripts in Visual 3D, as well as SIFs. We have like a batch processing command line version of the application for kind of streamlining and for these types of users who are performing this type of study. But the pipelines were able to analyze key events, kinematic quantities, spatial temporal metrics to describe how each runner was running at mile 20 of the marathon. And then they had kind of consistent definitions. So SIF's engine was able to apply the same model scaled uniquely to each runner with their metadata. So we were able to like merge in, okay, here's a big, huge information about the runners registered, and here's their data. Now let's put that all together and have unique files with all the same information and same processing for every single person. And then again, that streamlined process. So after they collected the 350 runners, they went back to the lab and basically pointed out a folder and said, here's all of the raw trials I collected that day. And under 10 minutes, they had all of their data processed and analyzed, or like the analysis spat out from from that kind of setup. So they were able to basically create this structure that's saying, okay, as soon as I get back from this marathon, this is what X, Y, and Z are going to happen, and I'm going to have everything done. And that was pretty cool to have that happen under 10 minutes. So that was a really fun project to kind of see some of the power that we're able to give some users and be able to provide them with some of our tools. And so I just wanted to touch on and actually show, hopefully you can still see this, but if you're curious about kind of this project in particular, but also just like how people are actually doing this in Visual 3D and SIFT, all the data from the Sanford Stride project is public. So if you want, I can maybe after we stop sharing, I can put the link in the chat, where you can just look up Sanford Stride project GitHub, and it should be there. But all of the data is here, so raw data. So we have all the like C3D files, data dictionary, which kind of describes what he has, like a huge metadata full file. So just kind of describing like what the terms are in the data. So that's what the data dictionary is. And then all of the information about each marathon runner. And then he also has like the Qualys specific stuff that he was working with. So templates, settings for the project, things like that. And then the Thea files, so preferences for how they collected did the pose estimation for these motion capture trials. And then all of the has motion files as well, which is super cool. So they have all of the Visual 3D pipelines that they ran, so all their biomechanical measures, what joint angles are we calculating, what gate events are we finding, how are we filtering data, everything there, and then also everything related to SIFT. So how are we creating these workspaces, how are we merging in their metadata and building their files, how are we processing and grouping and normalizing and cleaning and shaping our data, and then kind of what results do we want to spit out from each participant. So all of that is available. So if you're curious at all what that might look like, it also is just cool to see like with this project, like I'm sure like so much work went into kind of setting this up and making this happen, but to be able to have like all of this kind of process in 10 minutes and then be able to put up this data, and kind of just shows the scale at which we can, there we go. The scale at which we can collect data and then being able to share it so easily is like hugely important, and kind of shows, this type of project is super, super important for not only us as a community, but just for the next kind of generation of researchers. And like, this is going to be hopefully the standard of, we have this cool data, we did something really cool, we collected these marathoners, let's share this, and other people can start asking questions and using this data and kind of seeing the process that took. So yeah.
Perfect. And then the last one I'm going to share with you guys is a project based in Ostrava, Czechia. And this idea was what they've currently been working on. It's not a super new, it's about 5-year-old project. But one of the big things that happens with big data that can be a little scary is the idea of batch processing, and more importantly, batch reprocessing. When we're collecting data at this large scale, things change over the years, and just being able to not throw away old data and making sure that we can update it all at once and not spend months re-updating old data to be able to be useful. So this project is a very fun project, one that I'm somewhat involved in. It's under the Czech Republic, the government. It's the LURCO 4H study, healthy aging in industrial environments. So what they're looking at is it's this 5 years long project that is monitoring the health of people who are living in industrial regions of the country, and kind of looking at the impact of their physical activity or inactivity on their health, psychological well-being, and quality of life. But it's a very extensive project that they're doing. They're collecting over 1,000 participants with a large range of ages, 18 to 70, and they follow up 5 to 7 years from the initial study, and they have a very good retaining rate. I want to say it's like around 70%. But what's also really cool about them is that they are looking at biomechanics specifically, obviously, but they also have imaging methods. They have physiology and anthropology, functional anthropology, behavioral and cognitive data. And then also within this 5 years, they're constantly monitoring their physical activity and behavior. But if you would like to know, I would definitely take a look into it. It's very interesting. The first initial data collection is like a overnight stay at the university, and they've done a lot to make sure that it's a very equitable data collection, to make sure that anyone can be data collected and there's no barriers there. But they've been collecting this many participants for this long, and they have a lot of follow-up data that needs to get considered. So as I mentioned, the first wave had around 1,300 people. I tried to be as diverse as possible with who they're collecting, gender structure, obviously, age structure, and then activity structures. So because it's been such a large project, that the initial go was to look at this idea of industrial aging, but because they've collected so many participants and they've collected so much data on it, they can start to look at other questions from this data. So right now they're really focusing on this idea of inactive people and runners and seeing how injury can be caused from that. So lots of different participants. This was the first wave. They also have the second wave. So they've already at close to 1,000 again. So even 70% was a little too low for them. But yeah, they're almost at the 1,000 mark again in the second wave of data collection. And yeah, as I mentioned, very diverse data set that they're looking at. And even within the data, their signals are very extensive. So basically what they're sitting at right now is all this data some is very new that are just getting collected right now, and some are a few years old. And it's just being able to make sure that you're never at the point where you have to throw away old data because things have changed. So one of the challenges that they've been dealing with is this idea that after the second visit, they realized that they had to reprocess the data and update their model. So something with the foot segment in particular, they were wanting to change, which would have required a full recalc on all model-based items that are affected by this. And this could have taken
months for sure.
A couple days or weeks or months, etc. It would have really taken a lot of people. But they were able to use SIFT, reprocess all these data, just have a new model template, make sure it gets applied to all of them at once. You can run it once with all your workspaces loaded. And they were able to kind of run this pipeline, update, batch process, and reprocess this data to make sure it's all standardized. So now that when you're looking at the first, second visit, you can make meaningful comparisons, and they're not just a bunch of data that's not being thrown away, but just making sure that everything is getting considered. And this was able to be shown in their newest article. So again, what I was mentioning, kind of taking a different aim right now is the idea of looking at injuries in these runners from the study. And they were able to evaluate the lower limb biomechanics risk factors. They got some interesting results, and they're able to use this updated model to look at the beginning and end of the 5-year follow-up period. And that was just a fun little example that's still current, just being able to reprocess your data, which is not fun even if you have 10 participants, but really not fun if you have 1,000.
And I think it took like a couple hours.
Yes, yeah, it's something that's like you can with SIFT, and how they did in particular was just being able to reprocess it all at once, making sure it's standardized, and it did take a few hours, so it wasn't as daunting as it can be. But to sum that up, those were just a few different users that are currently doing some stuff with large scale biomechanics, big data sets, and some of the maybe not problems, but things they have to consider when working with this type of data. Obviously, this is not the only things that need to be considered and not the only people that are doing this. It's really cool to kind of see what's getting done, how people are approaching this problem, and what new things we kind of have to think about and maybe change our perspective on when dealing with these data sets. But yeah, that's what we have now. I think we'd love to take if anyone has any questions or anything you want to.
Questions related to this, related to Hasmotion, industry, any questions?
And I'll stop sharing here.
Yeah, so we can kind of see. But yeah, thank you all for listening.
Yes.
Yeah.
Oh, sorry, I was really struggling to unmute then. Thank you so much. Thank you so much. That was really interesting. I really enjoyed the way that you delivered it kind of via those examples. It was really nice. And the video, I think the first video you showed of the speed of the markerless, it was like blink and you miss it.
Yeah.
Like for the second bit. And it's just like done. I think I saw Caitlin's face when it done. She was like, oh. Does anyone have any questions? Feel free to raise a hand or just jump in or pop something in the chat. Oh yeah, Caitlin, so relatable. Yes. I mean, I think I was quite impressed with 45 minutes.
Yeah, totally.
I will mention though that last study I was talking, they're all marker based. So it's not to say that
you can't do big data without you can do that 1,300 participants marker based. I don't know how.
It takes a while, but
yeah.
So I'm gonna ask a question. Thank you again for the presentation. That was amazing. Like it was great information there. So I wonder about the shift that you mentioned. So I wonder how like we have Visual 3D which do all the like filtering and making the model and results. So then shift how like is it more like processing? We have like too many people that is gonna like make all those process smoother, or are just like a little lost on how the connection between these two?
Yeah, so they Sift and Visual 3D like can work well together. So like let's say you have kind of processed you do all your biomechanical measures and all your typical processing in Visual 3D. And if you're familiar, you'll recognize like a CMZ file, and that's like kind of what you create for each participant and how that's processed. But when people started collecting bigger studies, we realized like, oh, Visual 3D is very like one subject, one session level, and it's hard to like analyze across participants. It's not like super easy to do that in Visual 3D, and it kind of requires like exporting and going to MATLAB or Python or whatever, which is like totally a nice, like a good way to do it. But we realized, yeah, there is maybe that kind of limitation with Visual 3D, and we didn't. When Visual 3D was designed 25 years ago, it probably wasn't thinking about this case where we has people we want to look at. So what SIFT does is you can kind of point to a library of CMZ files, so the Visual 3D workspace files, and say like, okay, for all my participants, I want to pull out the left mean angle in the X component, and I want to like plot the group means between OA patients and standard and like patients. And so you can kind of look at all of your data, visualize, kind of inspect your data, like look at, like find anomaly traces, do PCA and SPM and different statistical methods as well for kind of group comparisons and stuff and metrics and things like that. So yeah, it's more like taking a big kind of picture approach of all of your data, but then also has the ability to kind of batch process and update. So for example, that Stanford Stride project or the Osterva project where they can reprocess all their data, you can actually start in SIFT with just like raw C3Ds and say like, hey, I have 100 C3D files. here's a model template and here's my pipeline of all the joint angles I want to calculate. Like, can you just go and do this for everyone and then give me the signals I want? So yeah, that's kind of how they work separately or kind of in contrast. Yeah.
Okay, great. Yeah, thank you. Yeah, got it.
Thanks
Yeah,
so
I
much.
usually use MATLAB to do that, but yeah, I see this gonna make it much more easier. So thank you. Yeah.
No problem.
Eva has a question. I assume this is related to the markerless motion capture, but whether there are any issues regarding low light or like mixed light environments.
Yeah, I think that one, I think as well, Maria, right underneath it. Both some Thea questions there. To clarify, we are not Thea. Common misconception there. But I will know that low light, the light definitely does have an impact on Thea. I don't want to speak 100% because again, I'm not entirely sure there, but it's definitely something to consider. I think the ability to collect it out of lab is a great thing, but even when you're in a real world situation, there's definitely still going to be some considerations there on what makes a good environment. I cannot go into specifics though, because I would not know.
No, definitely like having to test like lighting and things like that. Like I know like shadows and things like that can sometimes be an issue. But yeah, again, that's more of a collection question, which we are not kind of experts on the markerless software, but we are
once the data is collected,
then we know what to do.
And the same with you, Maria. I know there's quite a few comparison studies out there that I would recommend taking a look at. There's a lot that have been done on working with the how it compares to marker based.
Yeah. And then I think you asked too about what we presented on was mostly gate data. And kind of these solutions, for example, like Visual 3D and SIFT are very like customizable to your analysis. So we're not if you think of something like Qualys Path, for example, like they have specific path modules for gate and for golf and different activities. With Visual 3D and SIFT, you are kind of designing that process yourself. So you or the engineer or like someone in your team is kind of saying like, okay, these are the events for this activity and this is the measures we want for this activity. So you would have to set that up and customize that to your analysis. And we have lots of like examples of things but gate is just like an easy one that a lot of people are looking at, but yeah, it's totally customizable in terms of the markerless collection, but also kind of how these batch processing and updating and stuff works. And then Chelsea. Hi, Chelsea.
Hi, Chelsea. I think it's a good question. I'm not entirely sure we're there quite yet. I know the multi-centered studies that we have seen, the one that we showed was only Thea, so a common vendor there. I think it depends. I think it's hard to know. I think there's a lot of lab effects that we see, especially when we talk about different vendors. I mean, even if you talk about Thea, people working in different releases, things start to change. And I think having as much standardization is important. Also, in the sense that I think it's also important to know that it wouldn't make sense for everyone to collect using one vendor, use one software. That's not really how research works. We need to be flexible on what you're working with. I think so. Yes, I don't know. My answer is I'm not entirely sure if we see it being really used with different vendors, different types of motion capture. But I do also think that it is important to note that it's not just motion capture that makes up big data. I think what we really start to see when people get to answer really interesting questions is when there's lots of different modalities of data being used. Like it's motion capture, but then you have EMG and maybe you have a separate experiment these participants are also looking at. And maybe you have more clinical information. I think that type of different types of data, I think is a bit where we see kind of going with the idea of big data.
Yeah, I agree. I don't know right now, like if you could take, even if you got to the point where, okay, you have like your outcome measures and it's like, okay, here's my like set of knee joint angles for this subgroup of patients, and I used Thea, and then here's the knee angles from all another lab's patients who used OpenCap. I probably would hesitate to try to directly compare those at this point, unless you did even a validation study. I'm not sure.
Yeah.
Right now, but yeah, I agree.
Hopefully in the future.
Yeah. Hopefully we can get to that point.
Yeah.
Thank you so much. Just in the interest of everyone's time, I'll probably wrap it up there. There's just a small part of Maria's question you didn't answer. Does it include information beyond the lower limbs? I think the answer is yes.
Yes, but yeah, it's a full body model.
Yeah, I thought so. I just wanted to check. Thank you so much. Thank you so much, Sydney and Amy, for joining us, and really thank you so much for House of Motion for being one of sort of IWB's supporters, and we really appreciate everything that you help us with. And yeah, it's been really great to learn more about the company as well.